All right, so now that we have visualized the data and we've looked at the scatter plot and the regression line for number of children and weekly work hours separately as predictors of sleep hours, we are ready to jump into the actual regression analysis to see if number of children and weekly work hours are significant predictors of sleep hours. Just because we have a regression line and a scatter plot doesn't mean we should have any confidence whatsoever in our predictions. We have to first test the significance of it to make sure that it is actually predicting a significant amount of variance in sleep hours so that we could actually feel confident using the regression equation to make those predictions. All right, so I am just going to steal this data, and I'm not going to include participant ID. I'm just going to steal number of children through sleep hours, so my three variables. Copy those and put those in a new tab. Paste. And let's go ahead and name this tab. You can either double click it or you can click here and click rename. And let's name it regression. And let's just put ×2 because we're actually going to do 2 of those. So in our first analysis, we're going to do regression using number of children as a predictor of sleep hours. Then we're going to run the same analysis, but with work hours as the predictor, or the X variable of sleep hours, or our Y variable. So here we go. Go to data. If you don't have the data analysis tab, make sure you go to File, Options, Add-ins, Analysis Tool Pack, click Go, make sure it's selected, click OK, and then you'll have it. If not, you can leave and come back and you should have it then. Sometimes you have to restart. So we go to data analysis and we are going to select regression. Click OK. Now remember, with correlation and regression, our Y variable is the variable that we're treating as our dependent variable, our outcome of interest. And in this case, we're trying to predict the outcome of sleep. So I'm going to highlight this variable, including the label, all the way down to the end of the data. Boom. Make sure the label is selected. Make sure this box is clicked as well so that Excel knows you selected the label. Now our X variable in this first analysis is going to be number of children. So I'm going to click this box right here and then highlight including the words number of children all the way down here. Great. Output range, I want it to be right here, so I'm going to click that, then click the box, and then I'm just going to have my output start right about here. Okay, go ahead and click OK. Now let's go ahead and request the second one before we start doing formatting, because we can kind of double dip our formatting. So now let's go ahead and do it again. Data analysis. We're doing another regression. It saved our stuff, so we're just going to have to make some minor tweaks. Our Y variable is still sleep. That's still our dependent variable of interest. But this time we're going to get rid of number of children as X and replace it with our B variable, or typical weekly work hours. So just highlight that, including the label, right? Labels is checked, output range. If you leave it like this, it'll run the analysis and it'll paste over top of the one you already did. And we don't want that. So let's get rid of this and let's tell Excel that we would like this output to be down here, right below this one. And click OK. Now I can highlight all these columns and I've got both my outputs. I can right click, format cells, number, 3 decimal places. And I can go home, format, auto fit, column width, and now we have something worth interpreting. Okay, so if we take a look at our first output here, this is the one looking at number of children as a predictor of sleep hours. So this first piece here, this is the correlation coefficient. And this is the exact same thing that you would get if you did the math behind it, only you need to remember that Excel doesn't tell you if it's positive or negative up there, so you need to go down here to know that the correlation is actually negative between number of children and sleep. Okay, right there. Here's R squared. That tells you that 19.8% of all the differences or all the variability in sleep hours is related to how many children the students had. All right, some other important values, so I'll just bold those. So now let's have a look at degrees of freedom. Those are what you report in APA style. And we'll look at APA style in a little bit. This as well. We'll go in APA style. So actually, let's just grab it. So I'm going to make some magic happen here. Ta-da! All right, so APA style. Our degrees of freedom, 1 and 47. Boom, they're going to go right there. So you put the F first, right? Then you report your F value. We're going to round it to the hundreds place. It's 11.64. Comma, P equals, that comes from here. That's your significance. And then your R squared right there that I showed you, rounded to the hundreds place. There's that 0.20. Okay? All right, by APA style. All right, now let's have a look at my favorite part of this output, which is our coefficients. So if we see our coefficients here, we've got our intercept, coefficients, intercept, and number of children. So with some magic here, you see that your regression equation will be predicted hours of sleep, so the predicted Y, equals your intercept, this coefficient, which tells you what we would predict hours of sleep to be if X, or number of children, was 0. So it's like our starting point. So if you have no kids, your starting point for sleeps is about 8.85 hours. Okay? Then we always do plus whatever this coefficient is. Well, since this coefficient is negative, instead of doing plus minus, plus negative, you could just write it as 8.845 minus 0.596 instead of plus negative 0.596. All right? Then this is your X, right? That's just your placeholder for whatever number you wish to plug in to make predictions about sleep based on children with, right? All right. So you've got 8.845 minus this times this is basically how you would write that equation. Now let's create a quick macro to make predictions about sleep based on number of children. So I'm just going to kind of do that up here. Let's put macro, prediction macro. All right. So here, I want to set it up so that I can really plug in any value of number of children that I want to make a prediction about sleep. All right, so let's do a little formatting here. There we go. I'm going to center it too. I can't help myself. And I'll center the values as well. All right, so check this out. This is pretty cool. If you want to, you could even merge these, but I'm going to stop myself right there. All right, so here we go. We're going to create an equation here that we can program so that we can plug in any number of children and make predictions about sleep hours. And then we can take a look at it and see how it lines up with your scatter plot that you made in the previous video. All right, so here we go. To make this macro, you do equals. Okay, then remember, to get our equation, it looks like this. So we're basically going to program this equation into this. So it equals our coefficient plus this, and let's put it in parentheses, this times, right, number of children. And that's going to be whatever we want to plug in here. And then we can close it with a parenthesis and hit enter. So check it out. See how it says 8.845? That's because if this is blank, it just assumes it's 0, and that's our starting point. That's our intercept. Now, because our B coefficient here is negative 0.596, every time I increase this number of children by 1, you're going to see sleep hours decrease by 0.596 because that's how the regression equation works. This tells you that for each 1 point increase in X, what do we predict to happen to Y? So in this case, for each 1 child increase, we predict sleep to decrease by 0.596 hours. So watch it happen. If I put in a 1 here and hit enter, this magically goes down because of how I programmed it by my slope, right? By my B coefficient. 2, oh, it goes down again. 3 kids, right? Just keep popping out babies and watch that sleep just go away. So now let's quickly just confirm that if you had 6 children, you would be expected to sleep about 5 hours. If we go back and look at our scatter plot, 6 children, here's 5 hours, oh, right about there, right? So again, that equation is the basis for that line that magically appeared in your scatter plot when you clicked to request the linear trend line. All right, now let's have a look at our second output, looking at weekly work hours as a predictor of sleep. So here we have our correlation coefficient yet again. And yet again, it is negative, and we need to look down here to know that. So make sure you keep that in mind, because that's something with Excel that's a little bit tricky. Here is the R squared for that analysis, and this tells us that when we look at weekly work hours, it is predicting 28.5% of the variability or the differences in sleep. So 28.5% of all the differences in sleep is related to weekly work hours. All right, here we've got our degrees of freedom and our F statistic that we will put in our APA output. So let's go ahead and our APA write-up. So let's go ahead and have a look at that. Ta-da! All right, results from a linear regression analysis suggest work hours is, I said is because it's technically a variable, but you could say are because hours is plural, whatever. A significant, right, because this is less than 0.05, so keep that in mind. Predictor of sleep hours, which was our dependent variable. F, and then our parentheses, 1 comma 47 equals our F of 18.704, okay? And then you want to report your p-value as less than 0.001 because in this case our p-value is 0.000078922 and so on. So you have to put p less than 0.001 there to acknowledge there is some degree of probability that these results could have been due to chance, but it's just really, really, really low. So that's why we don't just put p equals nothing. All right, comma, r squared, that 0.29 rounded right there. Okay, so now let's take a look at the fun part. So if we are looking at our regression equation, which looks a little something like this, boom, all right. So our intercept, our starting point for sleep, if you don't have a job, you're sleeping about 9 hours a night, good for you. All right, so that's our starting point, our intercept. Plus negative can just become subtraction, right? So minus. For each additional hour you work per week, this model predicts you're going to sleep 0.056 fewer, or yeah, for every additional work hour, yeah, you'll sleep a 0.056 fewer hours. The reason this is such a small value, even though we have a significant number, is because there's a wide range here, right? This goes all the way up to 50. So there's just incremental changes in sleep for additional work hours because you could have 20 additional work hours, right? And that'll add up to a lot less sleep. So if we use our equation here and our macro, right, where we can plug in any value we wish for work hours to get a prediction, we could say, all right, here is our prediction macro. I love creating formulas and then just like plugging stuff in. It's fun. Okay, so here we're going to plug in work hours, weekly work hours, right? And then this is going to be the predicted value for sleep. So let's create our macro here. So we're going to do equals to tell Excel we're making an equation. Our intercept, 9.016. And then we can just put plus because that's how it always works and it'll know when it's negative. I like to put it in parentheses. Sometimes we could put this, right? Our coefficient for our x value, star for multiplication, our work hours, which is whatever we want to plug in here. Then we can close it in parentheses and hit enter. Notice this says 9.016. That's our intercept. That's our starting point because this is reading as 0 work hours. Now, because this is negative, we're going to see this decrease as work hours increases. And it's going to decrease by 0.056 for each additional work hour. So watch this happen. 1, right? And now if I go to 2, and then 3, all the way up to if somebody's working like officially part-time, right down the middle, 20 hours a week, 7.89. Let's check to see if that matches a scatter diagram based on this data. So 20 and 7.8. 20, go up to here. Whoop, that's close to 8, right? That's about 7.8. So I'm feeling good about my equation. I didn't make any mistakes. It matches my scatter diagram. Watch, if I go up to 40 hours, guess what's going to happen to sleep? It's going to drop, right? As work hours increases, sleep is predicted to decrease. All right, so I hope that after this you love regression a little bit as much as I do, and you can have fun making predictions with data in your real world.